Hey physics friends, and welcome to 17.2, which is an instructional video on how to reflect a ray off of a mirror using a compass and a straight edge. So we're going to spend some time today reflecting off of a mirror and giving you some ideas on how to use a compass and a straight edge to do that. Here's kind of what we're going to be working with. Right now, I've got an incident ray. Right here represents a laser light or a photon, whatever you'd like to think. And then down here is a mirror. So what we're going to do is we're going to bring this in, bounce it off the mirror at the right angle. And what we're going to be doing is using a laser to actually track how accurate you can be. So I'm going to give you some tips on how to be as accurate as possible, and we'll go from there. So pro tip number one. Your compass absolutely cannot be sloppy. Meaning this, like if you were to grab one of the legs of your compass and you hold it sideways, if that starts moving, that's not going to work. My compass has like you can turn this dial right here and it allows for really micro adjustments, really good. If yours is sloppy, there are things that we can do to fix it. Some compasses have a rivet, and I can hit that with a ball peen hammer to expand that rivet in the hole, create a little bit more friction, and it will work well. Or maybe your compass has a screw, and we can turn it with a screwdriver, and you can tighten that up. So just because your compass is sloppy doesn't mean we can't fix it. So that's number one. It needs to not be sloppy. Number two, your pencil needs to be sharp. So here's my pencil right now. That's definitely not sharp enough. So give me a second. We're going to go fix that. And after a few seconds in the pencil sharpener, this is a much better pencil that you need to be able to work with. Not only does your pencil need to be sharp, but the pencil that's in your compass also needs to be sharp. So make sure that you have a sharp pencil. Big fat lines are going to lead themselves to inaccuracy. Along with big fat lines, how to leave really nice lines. Twist your pencil, and you're going to see me doing this today. As I draw my line, I'm going to be twisting my pencil as I draw it, and it's actually going to sharpen the pencil as we make the line. If you don't twist the pencil, you're going to be filing basically a chisel point, a flat point, which is going to make the line wider and wider as you do it. And then lastly, draw light lines. When you grab your pencil, when we write, we kind of hold our pencil up here, but when we're drawing today, I want you to hold your pencil at the end so you make nice light lines and then you twist them as you go. So let's kind of get started. There's going to be two phases to this. We're going to end up making the normal, and then we're going to end up copying our incident angle as our reflected angle. So all these directions here today, they're basically two parts. Part one, making the normal, and then part two, copying the angle. So before we can even get started, we need to make sure that my incident ray actually hits the mirror. So what I'm going to do, I'm going to extend, and my straight edge is just a drawing triangle. So I'm going to extend my ray, and again, grabbing the end, and I'm going to twist my pencil as I do this. And it's okay that I go through my mirror. I actually went through my mirror a little bit, which is all right. We're going to reflect off the mirror, but this at least tells me exactly where that intersection is, because that intersection is important. Step one, open your compass to a large random span. Put the pointy part on the intersection of the incident ray and the mirror. Strike two small arcs on the mirror on either side of your incident ray. So I have my compass, and I'm going to open it up to a large span. Now, I don't want the span so large that it goes off my mirror. I'm going to put the pointy part here at that intersection. Now, again, if it was too large, you see how this, if I made my arc, it would be off my mirror. So I'm going to come in, strike my arc here, and on the other side, strike my arc there. So I've got two arcs on either side of my incident ray, and they're the same distance away. It's really important that when you go from one to the other, that your compass doesn't move. If it moves at all, you're going to have an inaccurate result. Open your compass to a larger random span. Put the pointy part on the intersection of the small arcs you just created in step one and the mirror. Strike a large arc above the mirror, and repeat this process for the other small arc that you did in step one. So I'm going to open up my compass to a larger angle. I'm going to put the pointy part, bigger is always better. Really open it up. I'm going to put the pointy part here, and I'm going to strike an arc. Really delicate, very fine arc that is not fat. It's very nice. Take my time, put the pointy part on that intersection, and make my other arc. I'm really interested in where these two arcs meet. So that's going to be an important part. And again, they can't be fat lines. They have to be nice thin lines if you want accurate results. Now we're going to draw the normal. Connect the intersection of the two arcs you just created in step 2 with the intersection of the incident ray and mirror with a long, short, long pattern. Label it as the normal. So what we're going to do, we're going to connect this intersection up here to the intersection of the incident ray and the mirror with a long, short, long, short, long, short pattern. Now, when I go to make my line through the mirror, make sure that you don't leave a gap. You strike it through the mirror. So I always want to make sure I can see where that intersects, because that intersection is important. And then we're going to label this normal. This pattern is known as a construction line inside of engineering, and it's really important that we do this pattern because as we move forward through this material, you're going to have so many lines on when we go through lenses and we do more complicated mirrors, that it's important to know which one is the normal and which one is the incident ray, and you can tell just by looking at this that this is the normal because it has that long, short, long pattern. Next, we're on to phase 2, copying the incident angle. Open your compass to a large, what we're going to end up doing, just to kind of give you a foreshadowing, I'm going to copy this angle. This angle is known as the incident angle. I'm going to copy this angle on the other side of the normal, and that's going to give me my reflection. So in a nutshell, that's where I'm going with this whole process. So open your compass to a larger random span, put the pointy part at the intersection of the incident ray and the mirror, and strike an arc through the incident angle through the normal to the other side of the normal. Let me show you what that means. So again, I'm going to open up my compass, and I want to make sure I'm going to put the pointy part right down here on all these intersections. I want my compass to go through the normal, and I don't want it to go through a gap, but I also want it to be as big as possible. So I'm actually going to open my compass here. See how it goes through the line? I'm going to draw this arc right there. And if you notice how I'm making my arcs, I'm holding the pointy part as if I were holding a pencil, and then I put this in here, and then I strike my arc that way. I don't hold the middle, I don't hold the other arm, I let that go freely. So that's what we should have for step 1 of the second phase. Next step, measure the incident angle. Put the pointy part of the intersection at the intersection of the incident ray and the arc you just drew in step 4. Open the compass to the exact span where the normal intersects the arc you just drew. So what we're going to do, we're going to put the pointy part right here on this intersection that we made. We'll put the pointy part, and we're going to use our compass to measure. We're going to use our compass to measure this span. So I'm going to keep closing my compass until I measure this arc right here. So that's a little bit, see how that's a little bit too big? I'm going to keep closing my compass. That's still a little bit too big. There. I have this on my compass right now. I've programmed that distance. I'm just going to copy this distance over here. So then I think I'm stepping ahead. You've got to make sure your compass doesn't move at this point. Put the pointy part here, and we're going to make an arc right there. We've effectively copied this angle over here with my compass. So do not move. Here we've already done number 6. Don't move your compass. Place the pointy part at the intersection of the normal and the arc you drew in step 4. Strike a small arc on the arc you drew in step 4. So you're getting this little, see this small arc right there? I'm getting that arc so I can copy my angle. Lastly, draw the reflected ray. Connect the intersection you just created in step 6 to the intersection of the incident ray and the mirror. Label it as the reflected ray. So I'm going to go back here, and I'm going to connect this intersection that I just made. I'm going to connect it with the intersection of the incident ray in the mirror. And again, grabbing the end of my pencil, twisting my pencil as I go. Here is the reflected ray. Now, some of the things, like we're going to actually take a mirror and put it down where you put your mirror, and we'll shine a laser along the incident ray. And you'll see how accurate you actually were through seeing this. Some of the big things that I see with people, number one, their pencil's not sharp. I see that a lot. Number two, I look down here. These lines all have to go through the same spot, and you'll actually see people not sending all the lines through the exact same point. Be very accurate when you're doing that. The next thing I see people's compass moving. I've got a special compass that I can actually measure with. It's got two pointy ends with no graphite on, and I can make sure that your compass isn't moving. So I'll see people's compass moving. I'll see them not drawing straight lines. I'll see them using really fat, heavy lines. If you want to be accurate, those are the things that you need to avoid. Now, it took me 11.5 minutes to get to this point. Actually doing this in real life is much, much faster. Probably a minute or less to do this. And you want to take your time. It's not a race. But let's go through this in real speed, start to finish, one more time. So on the back side of my paper, I have another one. So here's an incident ray. Step one, we open our compass to some span, and we want to make sure the span hits the mirror. Step two, open it to a much larger span. Strike two arcs above your incident ray. Make these arcs large, like make your spans big. Really small spans are hard to make accurate. Step three, draw our normal. So I'll connect this intersection with the long, short, long pattern. And when I go through my mirror, make sure I go straight through it like that. Now I'm going to copy my angle. So again, I open up my compass to some random span, and I want to make sure it goes through my normal right through a line. So this one will work. So I'll construct my arc. Next step, I'm going to copy my angle. So I'll put the pointy part here, as accurate as I can be, and I start adjusting my compass so that it goes exactly through that. Then I come over here, copy that angle, and then reflect it. There. That was probably a minute, right? Here's my normal. And here's my reflected. I want you guys to do this 2 more times. I want you to go through this process 2 more times on your notes before you submit them. Practice you'll get good. Make sure that you're looking down here. Are all my lines going through the same spot? Am I using straight lines? Am I using nice fine point? Is my pencil sharp? Am I twisting my pencil? Am I grabbing my pencil down here when I should be grabbing it up there to strike my lines? Good luck. Take your time. It's not a race. And we'll see you on the other side. One last thing I forgot to add is that this method also works for any curved mirror, any spherical curved mirror. So we're going to get to concave and convex mirrors as well, but this exact same process works in a curved mirror as well. And let me just quickly take you through a curved mirror reflecting. It's the exact same thing. Here I am. I've just sped this up, so I'm going at 4 times my regular speed, but I'm still extending it, making my arcs, constructing my normal, and then copying my angle to the other side.